Hello everyone. Plan for this recording is to talk through the composite function section. So let's get rolling. So far, we've covered addition, subtraction, multiplication, division of functions. So what that looks like is if I have these here, it would be f, nope. Wow, that's a big eraser. It would be f plus g of like 2, or it could be an x, or it could be f minus g, and so on. Okay, so far we've covered all these: addition, subtraction, multiplication, division. Plan for today is to cover this notation. This is called a composite function. It says take f and compose it with g, or it is f of g. So this is kind of hard to understand what it's telling me to do, but if I switch that to function notation, it looks like that. So our plan today is to discuss what this composite function means, which is this, talk about domain and range and all that good stuff of a composite function. Okay, so this is the biggest thing. This notation does not, big capital letters, not mean multiplication. This is not f times g. This is f composed with g, or f of g. And this would be another way of writing it. This we're used to. So what I would highly encourage you to do is when you see function notation, when you see composite function notation looking like this, I would rewrite it as our function notation where you have g composed, or g is put into f. That's what this means. Do f following g. That's the technical way of writing that. Do f following g, meaning do g first and take your answer and put it into f. That was big. Take g, evaluate g of 2 first. Take your answer from that and plug it into f. So if you think about it, the y values from g become the x values, and you plug it into f. Okay, let's just do this real quick. So g of 2 says take 2 and substitute it into the function g wherever you see an x. So I'm going to put a 2 right there. So g of 2 is 1/2. So now I have f of 1/2. Well, that says take the 1/2 now and go to the f equation and substitute in the 1/2 for x. So this becomes 1/2 minus 5, which would be a -4 and 1/2. So f of g of 2 equals a -4.5. Do g first, take the answer to g and substitute it into f. So this just means the opposite. Do f first, take the answer and put it into g. So f of 2, I put 2 right here. 2 minus 5 is 3. So this becomes g of a -3. Go to the g equation, substitute in the -3, and this becomes a -1/3, or 1 over -3, either way. Composite function. I would change this notation into this notation, and what it means is I take one function and substitute it into the other function. Okay. Your turn. Hit pause and give these two a try. Okay, hopefully you're back. I would, again, highly encourage you to change this notation into this notation. This says do the inside function first. I'm going to do g of 11. Take the g function, plug in 11 for x. 11 minus 7 is 4, and the square root of 4 is 2. So this becomes f of 2. I go to the f equation, I substitute in 2, and I get 5. F of g of 11 equals 5. Okay, this says do f first and substitute that answer into G. So f of 5, I cruise over here. 3 plus 5 is 8. And so now I'm going to evaluate G of 8. Put in 8 right here. 8 minus 7 is 1, and the square root of 1 is 1. So G of f of 5 is equal to 1. Or G composed with f at the point x equals 5 is equal to 1. Okay. Hopefully, now you know what to do. Give it a try. Hit pause, and when you come back, I'll do the problem for you. Okay. Once again, rewrite it. F of G of 1. Take 1, substitute into the G function for x. 1 plus 3 is 4. The square root of 4 is 2. So I get f of 2. Take the 2, substitute it in for the f function, and I get negative 5. So 2 squared is 4, minus 9 is a negative 5. Rewrite this, G of f of 2. So now I'm putting 2 into f first. 2 squared is 4. 4 minus 9 is a negative 5. And so I have G of negative 5. Put a negative 5 in here, and I get the square root of a negative 5 plus 3, which equals the square root of a negative 2. If we're only looking at real numbers and not looking at the imaginary numbers, this has no solution. And that's what we're looking at. We're only going to look at the real numbers for this topic, for this section. So when I plugged in 2, it didn't work. I got no solution. So now we're going to start talking about, well, what kind of values then work? What values can I substitute in from the very beginning? What is my domain of this function? So that's the next topic. So to highlight or to recapture what we just did, to evaluate this function, my first step is to do the inside. So I first do G of 1. I take that answer and I substitute it into the outside function. So G is my inside function. I do it first. The answer goes into f, which is my outside function, and then I solve. Okay. So what if it's down there somewhere? What if we just, well, let's look at this here. What is f of G of 0? So we talked about one function that didn't work. How about this one here? Before we do that one, yeah, never mind. Let's just go ahead and do that. So get rid of all this because it's kind of messy. Okay. Does this function work? What is f of G of 0? So this says put 0 into G. Putting in 0 for G, I get f of 1 over 0. Well, 1 over 0 doesn't make sense. It's undefined. So this has no solution. How about this one? G of f of 5. So if I plug in 5 into f first, right? So I rewrite this. This means G of f of 5. Do f of 5 first. So I put 5 into f. That worked fine. And now I have G of 0. But like we just said, G of 0 doesn't work. So, a couple different concepts. What is the domain of my original functions? What is the domain of my composite functions? That's the two concepts we want to look at. What is the domain of my original functions? What is the domain of my composite functions? So, first thing, if I want to find the domain of this, there are two functions we have to look at. What is the domain of the of the inside function? What is the domain of G? Why do I care about that? Because that's the first place I look. I take this x value and I substitute it in to G. So my first question is, what values work? Could I put in a 0? No. My domain of G is x can't be 0. Okay? So the next thing is, what is the domain of my outside function? So my outside, we're going to talk about that more later, because my outside function's domain is all real numbers. So I really don't have to worry about that one. So we're going to address this one here a little bit later. So the first thing you need to look at is, what is the domain of the inside function, the first function I have to deal with? And in this case, x can't be equal to 0. So in this case here, my domain is x cannot equal 0. And remember, we could put it in set notation. I'm not requiring it, but I could say x such that, so that's the set of all x such that x is not equal to 0. I could put it in set notation, but I'm not going to require that. Just x is not equal to 0 is fine. Okay, let's look at this guy right here. What if I'm going the other way around? Let me jump down here. Well, we'll go to here in a second. What if I'm going the other way around? What if I'm putting f into g? So what is the domain of f? What is the domain of my inside function? Well, domain of that's all real numbers, so I have no worries. Then why did this not work? If I have no worries about my inside function, why did the g of f of 5 have no solution? I didn't write it, but this has no solution. Why? Because my outside function, the g, does have a problem. And the value I happened to put in for x ended up being that one x value that I couldn't work with. So now what I have to think about is the output of this can't equal the value for x that we plug in for. Remember, what I get out of this one gets plugged into the input of this one. So what value can this, so the question is, if x can't be 0, when will x minus 5 equal 0? When x equals 5, which is why this didn't work. I take this function and I set it equal to what x can't be, and that will determine the domain of my composite function. Okay, so let's do generic f of x. I'm going to get rid of this whole thing. So what is, in general, what is f of g of x? This says take the function g of x. There's no number here, so I'm going to take all of g of x and substitute it into x into this equation. So f of g of x is 1 over x minus 5. Take this and substitute it in for x. Take g of x and put it into f of x. That's what function notation tells me to do. Take whatever's inside the parentheses, and that becomes my x value. So this happens to be a equation. So 1 over x goes into x. So what's the domain of this? X can't be 0. That's pretty obvious. X can't be 0. Okay, let's jump over to here. What is g of f of x? Now I'm going to take, sorry, I was trying to get rid of that arrow and I got rid of everything. So this says x cannot equal 0. That's my domain. All right, so this one here says take f now and substitute it into g. So I have 1 over x minus 5. X minus 5 is f of x. It gets substituted into x in my g function. So I have 1 over x minus 5. Looking at this function here, it's clear that x cannot be 5. What makes this 0? X equals 5. Why is that a problem? Because I can't divide by 0. And then once I do my substitution, I can see, oh yeah, x can't be 5 because I can't divide by 0. So my domain x is not equal to 5. There's my g of f of x. Go ahead and put the full notation here, and here's my f of g of x. Okay. I'm going to get rid of that. Let's cruise down here. I'll give you a second. Hit pause. Find what is f of g of x, what is g of f of x, and state their domains. right? So G goes into F. I take F and I put G into it. So take this expression and I put it into F. So this becomes 3 plus the square root of x minus 7. What is the domain of this? Well, this one has no restrictions, and this one does have a restriction that x has to be greater than or equal to 7, right? This has to be positive. So x needs to be greater than or equal to 7. Same here. The fact that this has no restrictions, the only restrictions would be then whatever G has restrictions on. And so my domain, x is greater than or equal to 7. How about this one? G of f of x. So now we're looking at taking this 3 plus x and plugging it in. So I have the square root of 3 plus x minus 7. And so I have a domain of, well, I have a expression that says x minus 4. What's my domain? This one's, remember how we talked about the output of this has to make this work? I'm going to do it a little different. I'm going to do it a little easier way. Just look at this function. What is the domain of this? Well, x has to be greater than or equal to 4. We'll go back to what we said earlier, just so we can see that I'm not just making things up as we go. This is my output, which becomes my input. So I'm going to take this and plug it into the domain of x. This says x has to be greater than or equal to 7, which means that 3 plus x has to be greater than or equal to 7, not 3. How about 7? And let's solve. Subtract 3 from both sides, and x is greater than or equal to 4. The output of this entire function gets substituted into my domain expression for x, and then solve it, and I have my new expression. Or just look at the new function and see what the domain is. But don't forget about any restrictions on the original function. And that comes up right now. Try this problem. Oh, I forgot to move them down. That's fine, we can see them. What is f of g of x and what is g of f of x? I'll give you a second. Solve those. Hit pause and come back. Okay, so this, again, I always highly encourage you to write that just so you are comfortable with the notation. I'm going to take g and put it into f. I'm taking g and putting it into f. Think back to our last section. A square cancels a square root, and I get x plus 3 minus 9, which is just x plus 6. No, x minus 6. Is there any restrictions on that? I want to see it both. I'm going to rewrite that thing. Maybe. Let's rewrite that as x minus 6. So this equals x minus 6. What is the domain of x minus 6? Anything. So what we would think then is, oh, my domain of the combination or the composite function f composed with g is all real numbers. Not true, right? We just had one. Well, that one wasn't the problem. What if I wanted to evaluate, let's go back to here. What if I want to evaluate f of g of negative 9? Does that work? According to what we're kind of thinking down here, anything works, right? X minus 6, there's no restrictions. So why does this not work? Because when I put the negative 9 into my original function, I get a number that we can't evaluate. I get a negative inside the radical. So when you're looking at the composite functions, you must first, well, at least some point in time, I would highly recommend first, look at the domain of each. Domain of this, all real numbers. The domain of this, x has to be greater than or equal to a negative 3. So now when I get to my composite function, the domain of the inside function, the first function you're dealing with, has to be accounted for. I can't put something in to my inside function that I can't evaluate. So if the first thing I do is I plug in a negative 9, then that has to be able to be evaluated, and it can't. So I have to go back to this domain, and even though this is all real numbers, my original function is not, or the inside function is not. So the domain of this guy is x is greater than or equal to a negative 3. So that's where you have to be careful when your composite function changes what the inside function is. This square root switched from a square root to a linear equation because of the square. Because these are inverses, they canceled each other out, and I changed what function I'm looking at. I have to be really careful when that happens, and I have to always go back to the inside function and check its domain. So my inside function here is f. The domain of f is all real numbers. I'm going to have no problem with this one. In terms of, I don't have to go back and think about what the domain is of the inside function. All I need to do is look at the outside function, or the composite function. I get x squared minus 9 plus 3, which becomes the square root of x squared minus 6. This will make you think a little bit. What is the domain of that? I took x squared minus 9, and I substituted in for x, and I did a little simplifying. And we already talked about the domain of this is no worries. I can put anything I want in for x, so my only issue is this guy right here. Remember what we have problems with? This needs to be positive. So when will x squared minus 6 be positive? Think about it carefully. I'll give you a second. I would hit pause even. Think about, when will x squared minus 6 be positive? Okay, let's do the easy side. I'm going to do a number line because number lines help sometimes. So we know that at square root of 6, right, square root of 6 squared, I want to know, when will x squared minus 6 equal 0? Okay, let me backtrack. If I want to know where something is positive or negative, then my first step is to figure out, well, where is it equal to 0? And then look to the left and to the right. So my first question then is, where is this thing equal to 0? So I add 6 to both sides, and x is equal to the square root of 6. So when x equals the square root of 6, this thing is 0. So which side of the square root of 6 would make it positive? Well, numbers that are bigger than. So I have square root of 6 or greater than works. Well, hopefully you said, Minogue, you forgot something. I hope you did that, because right here, when I square root a square, I generate both the plus and the minus, right? So this is also equal to 0 at square root of a negative square root of 6. So which values, one to the left or to the right, make it positive? Well, if I put in, let's put something over here. How about 0? Put in 0 for this. Well, that's a negative number. I don't want a negative number. I want a positive number. How about put in a negative 5? Something way down here. Negative 5 squared is a positive 25 minus 6 is greater than 0. So everything less than negative square root of 6 works. So what's my domain? My domain is x equals negative infinity to negative square root of 6, unioned with or combined with square root of 6 to infinity. Get rid of this because I don't need it now. My domain is all of this and all of this. When you have something like this, make this equal to 0, and then just ask yourself the question, is it on this side or is it on this side? Okay, I'm going to do something that just because I think it's really good to see it visually, and hopefully it doesn't confuse you. Here's what I also want you to see. When is this greater than 0? Think of the graph of that. Think of the graph of y equals x squared minus 6. And the output of this is equal to my y. So what does that graph look like? It goes down here, 1, 2, 3, 4, 5, 6. My vertex is at negative 6, and it hits the x-axis at negative and positive square roots of 6. And it goes like this. It's a basic parabola, right? So where is it positive? Where are my y values positive? Anywhere above the x-axis, right? Anywhere to the right of positive 6 and to the left of negative 6. That's a nice visual to visualize a parabola cruising through here, and they're positive over here, and they're positive over here. You don't need to do this, but it's sometimes really nice to visualize that and to see, oh, they're positive everywhere above, and they're negative everywhere below the x-axis. Okay, that is composite functions. I'm not 100% we got it, so I'm going to give you a couple more practice problems before you run away, and then you can go try the homework. So here's f of x. Here's g of x. The square root ones are hard, so we'll do a square root one. And then fractional ones are also hard, but they're not near as bad. And we'll do square root of x minus 9. Okay, so there's your functions. Before you run away, let's just try f. I already wrote it in the right notation. F of g of 11. And let's do g of f of 1. No. 2. No. Sorry, 3. I'm trying to get one that works. I'm kind of gave away my answer. So you know this is going to work. So f of, how about 3? That'll work. And then do f of g of x and state the domain, and then do g of f of x and state the domain. When you're done, come back. Hit pause, then come back. Okay, plugging in 11. 11 minus 9 is 2. And so this becomes a square root of 2. Putting in 11 into g, 11 minus 9 is 2. Square root of 2 is just square root of 2. Now take the square root of 2 and plug it in for f. So it's the square root of 2 squared plus 3. Square root of 2 squared is 2, plus 3 is 5. Hopefully you got 5. And if not, you can see how I got 5. Okay. Do 3 into f. Take 3, plug it in here. 3 squared is 9. 9 plus 3 is 12. So now I do g of 12. Put 12 in. 12 minus 9 is 3, and I get the square root of 3. Okay. Take g of x and put it in for x. So this becomes the square root of x minus 9 squared plus 3. That becomes x minus 9, and I get x minus 9 plus 3, which equals x minus 6. Oh, wow, that's very similar to our last one. So then this domain looks like it's all real numbers, but this domain says that x has to be greater than or equal to 9, so my composite functions domain has to be x is greater than or equal to 9. Has to make g of x true. Okay. G of f of x. Take this and substitute it in over here. So this becomes the square root of x squared plus 3 minus 9. Oh, it's the same one I had. Is that really the same one I had before? Really close. I just have the 9 and the 3 switched. Wow, sorry. I just made it up off the top of my head. I like 9s and 3s. So I have x squared minus 6. And then so this becomes just like we had before. Bummer. That's all right. I think you got the idea. So x has to be greater than or equal to the square root of 6, or x has to be less than or equal to a negative square root of 6. And that was from the number line that we did earlier. And if you want to go back and check out my drawing, you can. I wrote it a little different. I wrote it in inequality notation instead of in interval notation. Either way is fine. You can write it like this, or you can write it like this. Either one is fine. Okay. Give the homework problems a try. When you come back, we'll do more. Good luck.